It's been over a decade since AWS and Intel began our journey together. We've combined the depth and breadth of AWS cloud services with the performance and dependability of Intel custom processors, so our customers can build tools for the fast-growing future. Together, we're making technology more accessible by optimizing our global infrastructure. And we're reinventing the capabilities of data and analytics with powerful AI through an engineering collaboration that pushes the boundaries of innovation. But it wasn't these ideas that changed the world. It's how AWS customers use these innovations to bring their own ideas to life. It's how Fred Hutchinson Cancer Research Center can analyze data from more than 15,000 biological samples. A process that previously took 7 years of compute time now takes just 7 days. It's how the Australasian Wildlife Genomics Group at the University of Sydney can support conservation efforts of native wildlife by reducing genomic analysis time from 10 days to 5 hours. It's how Europe's Delivery Hero shortened their monthly billing runs, a 20-hour task, down to 90 minutes. And we're excited because this is only the beginning. Today, AWS and Intel are working together to put our most advanced technologies into your hands, so you can think bigger, build better, and innovate faster. Whether it's tomorrow or 10 years down the road, we can't wait to see what you do next.
Please welcome to the stage Darren Hardman, VP and General Manager, AWS UK and Ireland.
Well, good morning and welcome to the AWS Summit London. It is really amazing to get everyone back here together and to see so many smiling faces. We really, really appreciate that you've taken a whole day out of your busy schedules to be with us here. And it's going to be a fantastic day. I want to make sure that you leave feeling motivated, energized, and inspired to do some amazing things. Getting you all in one place has been a really long time coming, and I hope you enjoy the chance to meet face-to-face, to collaborate, and to, really importantly, have some fun. We have over 10,000 of us here today, and over 100 sessions that cover a broad range of topics, from business transformation right through to the very deepest of technical deep dives. In addition to the sessions, we have some super cool things going on. We have the Deep Racer League, we have the Ask an Architect sessions, we have the Startup Loft, and a number of tech for good innovations on display out there at the Innovation Hub. So please make sure you take some time to go and explore. I'd also like to say a huge thank you to our sponsors. Our global diamond and platinum sponsors are absolutely critical to our summits, not just here in London, but across the world. And we're hugely grateful to our sponsors who've made huge investments in terms of their time, their people, money, just to make today possible. And many of these sponsors have been with AWS Partner Network since day one. In fact, this year marks the 10-year anniversary of the APN. And over the past decade, those partners have guided our customers as they innovate and transform and play an integral role in the AWS ecosystem. Now, later on, I'm going to welcome Dr. Matt Wood, who's our VP of Business Analytics, who will talk about how AWS is powering the next generation of applications and how to harness the value of data. But before that, I wanted to share how AWS is helping to create a thriving digital economy in the UK and supporting UK businesses to unlock their ambitions, opportunities, and enable them to grow and innovate on a global scale. Now, the last few years have been challenging. The pandemic has had a sudden and profound impact that forced businesses and governments to pivot really quickly. And at AWS, we're really proud of the way we supported our customers to help them keep their businesses running, keep classes going, or speed up healthcare and research. And yet, as difficult as the pandemic has been for businesses, it's also acted as a catalyst for cloud adoption and digital transformation. And we've seen more and more companies turn to the cloud to unlock new customer opportunities. Today, organizations from the fastest growing startups to the largest enterprises, public sector organizations, and government agencies are using AWS to be more agile, to scale, to grow, and to innovate faster. Customers like EasyJet, Deliveroo, Sainsbury's, Genomics England, and Wise, just to name a few from this slide. And one of the logos on this slide that we're incredibly proud of is Kazoo. Kazoo, the online car retailer founded in just 2018, have innovated and transformed an entire industry. Kazoo wanted to scale quickly to retain its first mover advantage and turned to AWS and our partner Quadrant to create a new way to modernize and transform the used car market. And boy, did they do that. And to tell you a little bit more about their exceptional road to success, please welcome Bob Gregory from Kazoo.
Good morning, AWS Summit. My name is Bob. I'm here to talk to you about how Kazoo used AWS technology to build one of the fastest growing startups in Europe. So Kazoo is an online car retailer. Our mission is to transform the way that people buy and sell used cars in the UK and in Europe. And from the outset, Amazon was an example to us. It's like 3 a.m., you want to buy a toaster, you go to smile.amazon.co.uk, you find the toaster you want, you click buy it now, somebody brings it to your house a couple of days later. That's the model that we wanted for used cars. Simple, convenient, trustworthy. So Kazoo is a 3-year-old business. The first hires into the technology team were in April 2019, so almost exactly 3 years ago. And Kazoo is a vertically integrated business. So we own all of the cars on our website. We buy them from auction houses or direct from customers. We refurbish them at one of our 11 purpose-built sites across the UK. We refurbish hundreds of cars a day, 24 hours a day, 7 days a week. And we run our own internal logistics network. So we move thousands of vehicles a month up and down the length and breadth of Great Britain, and now making forays into mainland Europe. And all of this is very complex. So it is Wednesday morning. You could go to the Kazoo website right now. You could browse about 6,500 cars. You could buy one before the end of this talk. And depending on where you live, we could bring it to your house by Saturday. This takes an awful lot of software. So Kazoo is 3.5 years old. in a complex market, a fully vertically integrated business, Kazoo moves very fast. So we were the fastest British company to ever reach unicorn status after just 6 months of trading. And about a year later, we debuted on the New York Stock Exchange. Kazoo is not just a unicorn, though. Kazoo is an extra special, magical, serverless unicorn. So we have been all in on AWS since day one. And everything that we have built in-house at Kazoo is built with serverless technologies. And I submit to you that this is not a coincidence, that our technology choices directly contribute to our speed of execution. So what is serverless? Serverless is where you pay somebody else to run the infrastructure for you. So these days, that tends to manifest as pay-per-request pricing models. So in the olden days, you would hire a server from somebody for a year or a month or an hour. In the new model, we pay a fraction of a penny every time somebody visits the Kazoo website. And it's not that pay-per-request models are intrinsically better. It's that pay-per-request models require that the provider does all of the hard work for you. So at Kazoo, we use a handful of fully managed services in preference to everything else. We use S3, Lambda, Dynamo, EventBridge, API Gateway. This gives you storage, compute, online transaction processing, message-oriented integration, and HTTP communication. This is 90% of everything you need to build any line of business use case. So a typical Kazoo application might look like this. We'll have an HTTP API for customers to interact with. We store our transactional state in a Dynamo database. If we need to send data to another system or receive data from another system, we prefer to do that through business meaningful events that we put onto EventBridge. This system might comprise 10 or 15 Lambda functions. It supports a single business process or capability. It's in an isolated account. And the teams that own it are free to deploy and change it at will without dependency on other teams. This philosophy governs our approach to analytics as well. So those events that we raise form a natural source of rich telemetry. Our analytics guys gobble all that stuff up, stick it onto a Kinesis fire hose, dump it into S3, and then we can run analytics over it. Amazon run this for us, and they charge us per gigabyte stored and per query executed. So adopting these technologies means that Kazoo are optimizing for low total cost of ownership and, importantly, for rapid startup time. So in my previous job, also at an e-commerce company, we built an internal platform as a service. We ran a whole load of AWS EC2 instances. We ran Nomad on top of them. We had like console for configuration, like a ridiculous amount of HA proxy for routing, and it was great. Engineers could write code, ship it in a container to the cloud. They didn't have to think about where their compute was coming from or what the IP addresses were for their backing services. But that took us 5 years to build. Not 5 years to deploy the components, but 5 years to build the operational expertise to select and configure those components in the first place. And 5 years is a very long time. So by comparison, Kazoo built the first version of their website in about 90 days. So at the beginning of August, there was nothing. And by the beginning of December, you could go and you could buy a car on a credit card on the internet, and we would deliver it to your house 72 hours later. And I don't think we could have done it that quickly if we also had to deploy and manage all of the infrastructure. Since startup, Kazoo have hired roughly one engineering team every 3 weeks. We've scaled from 0 people to 450 people in the technology team. We hire people from a wide range of backgrounds. We teach them a little bit of TypeScript, a bit about Lambda. In the space of an afternoon, engineers can learn to build and deploy their first Lambda functions because the infrastructure is very simple. We've done a huge amount since launch, right? So we've sold over 60,000 cars. Our year 2 revenues were £668 million. Need to get that right or PR will tell me off. We've launched in France and in Germany. And meanwhile, I have applied 0 security patches. I have filled up 0 hard drives. I have restarted 0 servers. I have failed over 0 database clusters. Okay? Usually at a high-growth startup, you spend your whole time in the firefighting loop. The traffic goes up, the infrastructure goes down, you fix the bottleneck, and you repeat. At Kazoo, we've avoided that loop because our infrastructure is Amazon's infrastructure. The bottleneck for our database is the bottleneck for DynamoDB. The bottleneck for our web server is the bottleneck for API gateway. Amazon has spent $1 gajillion to scale this infrastructure far beyond what we will likely ever need, and now they rent it to us at fractions of a penny per request, so we only pay for what we actually use. So what's next for Kazoo? We've proven that people will buy cars online and that we can get them to their houses. Next up, we're focusing relentlessly on improving our gross margin. And again, AWS will be central to that transformation. Particularly, we'll be looking at how better data can help us make better decisions, how we can apply machine learning models to improve our pricing algorithms. And as we roll out across Europe, our lightweight infrastructure will make it faster, cheaper, and safer for us to deploy services to customers across an entire continent. I'm Bob. Thank you very much for listening.
Well, thank you, Bob. What a inspirational story. And it's just so great to see and hear about how AWS and our partners have helped you to scale. It really does inspire us to continue to create the conditions for organizations in the UK to unlock the opportunities by cloud technology. As such, we recently announced plans to invest more than £1.8 billion in the next 2 years building and operating data centers in the UK to meet the growing needs of our customers and to help strengthen the UK's digital infrastructure. This includes investments in skills and training and sustainability, areas that are increasingly relevant for customers in the context of cloud adoption. This investment is important because we know there's a huge opportunity for businesses to embrace the benefits of the cloud and to level up cloud adoption across the country. For example, if we could boost cloud prevalence in the Northeast to match that of London, we would help increase local productivity and wages to the tune of £1.4 billion, and that's just one region. However, to realize these benefits, we need the skills. And a recent study found that 11 million people in Britain require digital skills training over the next year to keep pace with technological advancements. And to help this, at AWS, we've committed to investing hundreds of millions of dollars to provide free cloud training globally, including here in the UK. And this includes a number of programs such as AWS Educate, AWS Academy, and AWS Restart. We're proud of Restart, created here in the UK in 2017 as a way of building an inclusive and diverse pipeline for new cloud talent. The program has now scaled globally, and it's focused on preparing learners who have little technology experience for careers in the cloud at no cost to the learner. And the program also connects learners with potential employers, and Restart graduates have secured jobs at organizations such as Cancer Research, BT, and the Financial Times, to name just a few, and many, many of our partners. And I'm delighted that some of our Restart graduates and learners have pride of place here in the front row today. If you want to find out a little bit more about how Restart can help your talent needs, then please speak with one of our brilliant collaborating organizations, the Prince's Trust, at the Innovation Hub later today. AWS Get IT is another program that was first piloted here in the UK. Get IT encourages students aged 12 to 13, in particular girls, to consider a career in technology and invites schools to participate in a competition to create an idea for an application to solve a real issue faced by their school or by their wider community. And I'll be helping to judge the final right here today at 12 noon in Theatre 3. So please come along and support these amazing teams who are helping to shape our future. Another area where innovation and technology are key is sustainability. When our customers transform, being sustainable is now a fundamental part of this. And in 2019, Amazon co-founded the Climate Pledge. As part of this, we committed to powering our operations with 100% renewable energy by 2030. And we're on a path to achieving this by 2025. That's 5 years ahead of our original target. In fact, Amazon is now the largest corporate purchaser of renewable energy in the world. And Amazon's first UK renewable energy project became operational last year. This is the first of 5 large-scale renewable energy projects that will power AWS operations in the UK. Our scale and focus on innovation means that we can achieve higher resource utilization and energy efficiency than is possible for the typical on-premise data center. In fact, research shows that businesses that move to AWS can improve energy efficiency and reduce carbon emissions. AWS infrastructure is 5 times more energy efficient than the average European data center. And when businesses can potentially reduce carbon emissions of an average workload by 96% when AWS reaches its global goal of purchasing 100% of its energy from renewable sources. We're also helping organizations to build their own sustainability solutions, ranging from carbon tracking to energy conservation to waste reduction. And our sustainability team is here at the Innovation Hub, so please go and chat to them and see how we can help support you today. We continue to work towards creating the right environment for businesses to prosper and to compete on the international stage, and for new ideas to grow and to flourish into new businesses born and raised here in the UK. Looking ahead, we continue to be excited by the potential to support our customers, partners, and citizens across the UK to help them unlock their ambitions. So before I welcome Matt to the stage, I wanted to say again, thank you for taking the time to spend an entire day with us. This day is for you. I really hope you enjoy it. So let's keep moving forward. And to talk a little bit more about the trends we see globally, please welcome Dr. Matt Wood.
Good morning, everyone. Can you hear me at the back? Give me a wave if you can hear me at the back. Waves all around. Thank you so much. Good morning, everybody. Thank you, Darren, for the warm introduction. And we've already heard from some customers this morning. But it is fantastic to be here with all of you in person for the AWS Summit in 2022. I've been at Amazon coming up for 12 years now. And I was lucky enough to attend and speak at, I think, the very first London Summit. We had a rented office just outside Mayfair, and I think we had about 150 customers attend. So things are a lot different now. We have thousands of people here in person, and it is fantastic to see you all. And the AWS business itself is also very, very different. Back then, 10, 12 years ago, you'd only have to say the words cloud computing, and myself or one of my 2 colleagues based in Europe would come and jump on a flight, and we would come and talk to you about the opportunities of cloud computing. And those conversations were always about, well, what are the benefits? Why should I move to the cloud? And today, those conversations are almost always about, how do I move to the cloud? How do I move to the cloud more aggressively? How can I make better use of the cloud inside my organization? And today, we have millions of customers in virtually every industry. Small startups, people in their pajamas just getting going with the next big idea. Fast-growing startups that are moving incredibly quickly, finding product market fit and growing their businesses, to very, very large enterprises who initially often start to look at the cloud as a way to reduce cost, but find the benefits lie increasingly in the speed and agility that it gives to their teams and their builders, as well as large organizations inside the public sector, and over 100,000 partners that are available to help you and your organizations move to the cloud more quickly. So as we've got all of these customers and as we grow the AWS capabilities, one of the things we hear time and time again is that customers base their decision of cloud platform deeply on the broadest and deepest service capabilities. And we have over 200 services available on AWS today. Everything from compute to storage to databases, through to robotics, augmented and virtual reality, machine learning, analytics, you name it, we probably have a service to do it. And the reason for that, and I know it can be a little bit overwhelming to look at these big, long lists of services, but the reason we do that is once you're in the door at AWS, you really don't want any barriers between your idea, which could be the next transformative idea for your organization, or the next transformative idea for your own customers. You don't want any barriers between that idea that may come to you in the shower in the morning and the delivery, prototyping, and then scaling of that idea, no matter what their idea is. And so this broad set of capabilities allows you to just follow your nose. It allows you to satisfy your curiosity as to whether your idea has legs, quickly, cheaply, and then take it out to whatever size scale your customers demand. And it's not just the breadth of those capabilities, but it's the depth of capabilities inside each one of those services. Inside each one of those services, you'll find all the features that you need to be able to quickly, cheaply, and efficiently spin up your idea and actually take it out to customers and start trying it on board. So AWS is an engine for driving your ideas. It's an engine for satisfying your curiosity. But we don't just stop there. One of the things customers tell us over and again that they love is that when they wake up in the morning, often AWS has shipped just a broad set of net new capabilities onto the platform. They didn't have to do anything. Those net new capabilities were just there. Last year alone, in 2021, we shipped over 3,000 major new services and capabilities onto the platform. And we're on pace to do at least that, probably more than that again this year. And so this is a tremendously transformative impact for your teams. Gone are the years where you had to go buy software, install updates, manage those updates yourself. And in is the idea that those new features are just available on a regular, rapid clip, and those features are almost always driven by customer demand. So if you have any ideas for things you'd like to see us build, please just let me know. You can find my email. It's matthew@amazon.com. And it's not just the breadth, it's not just the depth, it's not just the pace of delivery. Customers also love that they can take their ideas global in a matter of minutes with a large, significant global infrastructure, which is ever expanding and is already larger than any other cloud provider. So no matter where your customers are based, no matter where you want to take your business, AWS has infrastructure and resources in that location to allow you to build that idea and take it globally, literally in minutes. And whilst it's not the most important metric, this capability and speed has been recognized by other analysts. This is the Gartner Magic Quadrant, it was published last year. I'm sure many of you are familiar with the Magic Quadrant, but if you're not, like any good Business School 101 graph, up and to the right is better. And you can see AWS up there in the top right-hand leaders quadrant. Okay, there we go. Okay, so whilst today we have a pretty broad set of capabilities, and those capabilities are deep, and those deep features are being added on a regular clip, and those deep features are available globally, it wasn't always this way. And some of you may not be familiar with just how painful life was before the cloud existed. Or maybe some of you are going through this today. But without the cloud, things look very, very different. To start with, if you've got a new idea that you have in the shower, you can't just spin up the services and get going. You have to file like a bunch of paperwork. You have to write down your idea, you have to go present it to a bunch of people, everybody has to agree that that's what you want to go do. Before you even write a line of code, before you test whether that idea has legs, you've got to fill in just so much paperwork. You've got to put it all in writing. And then, if everybody agrees with your idea, then you get the opportunity to write a really big check. A check which is a capital investment in infrastructure, which you can go buy for yourself, and then you get the opportunity to maintain. You don't just get that infrastructure in minutes. You usually have to wait quite a long time, not just minutes or hours, but often days or weeks. And after you've waited days or weeks or even months, what you get isn't a service. What you get is just some cardboard boxes in your loading bay. And from there, you get the opportunity to rack and stack and cable all of that infrastructure. you get to download and install a whole bunch of software. You get to keep that software up to date over time. Then you get to power and you get to cool that infrastructure for as long as you want to run it. And as you might imagine, this makes developers very sad. It doesn't inspire them to take their best ideas and implement them. It doesn't inspire them to be constantly looking for ways to improve their product and their business for their own customers. It just makes them sad. But what makes them sadder is that eventually somebody will say, hey, great job. Let's do it all again next year. And they get the opportunity to write more paperwork. They get the opportunity to write another huge check with capital outlay. They don't just wait minutes or hours. They then wait weeks or months before the hardware arrives on the building dock. They get to rack, stack, and cable all that infrastructure, install the software, go ahead, power, and cool all the hardware. And this makes them just very sad. All of that cognitive work, all of that excitement of their idea is dissipated by the time the actual capability to execute is available to them. And there's nothing more demoralizing. There's nothing more that will shut down the excitement of your teams than having to go through that process. And just all of that disappears with the cloud. And when it's been incredibly exciting over the past 12 years that I've been at the company and longer that I've been using AWS as a customer, to see so many companies be able to take these ideas of elastic infrastructure, which is delivered as a service, and to be able to build extraordinary products with it. Whether they are large organizations like Capital One and Philips, whether they're small startups that have grown into enormous successes like Airbnb and Intuit, or whether they are public service customers like the Ministry of Justice who are getting going on their cloud journey. It's tremendously exciting. And what we hear from these customers when we talk to them is that they love the new ways that are available to them to build applications because of the services that are available on AWS. If you're building what is very common, a collection of web and mobile applications for your customers, there's multiple different ways that you can do that depending on your needs. And any sufficiently advanced technology, which is likely to be indistinguishable to magic to most of your customers, will probably fall into one, but probably multiple of these different categories. Whether it's traditional 3-tier web applications, where you have a database front end, a database back end, and then a database underneath it, or whether you have a microservices architecture, where you're using containers to be able to put small components together in any conformation that you want, or whether you're eschewing containers and servers altogether and just going serverless, just writing your code as a function which runs whenever it's necessary, or whether you want to go down the route of writing no code at all. This is an incredibly powerful way of getting quickly to market, of getting an idea into the hands of your customers. And so even if you're a developer, I wouldn't underestimate the power of not having to write any code. There is no code that you can write which is better and more maintainable than writing no code. And we have a range of capabilities, whether it is Amplify Studio, which allows you to take your React code and your usability mocks and put them together and deploy them as an application at zero cost, or a set of capabilities which allow you to manage and run, provision all of your containers. We have AWS Lambda, which allows you to write serverless, event-based driven architectures, or Amazon Honeycode, where you can just import some data, generate a UX, and then push it out as a mobile app in a matter of minutes without running a single code. All of these are accelerants for the innovation and the accelerants for the business that you're running. It also allows you to take advantages of the invention and the innovation that AWS puts in under the hood. And so if you just take, for example, one of the foundational core primitives of the cloud, compute. It's pretty big, pretty important capability. And we have an invention inside Amazon that we call Nitro. It's a set of hardware that we custom designed and software which allows us to really drive efficiencies of very, very large fleets of servers. And it's done by replacing one of the largest, most complex pieces of code in the entire cloud computing stack, the hypervisor. The hypervisor provides a set of APIs for managing CPU access and memory access for instances which run on a piece of physical hardware. The trouble is that most hypervisors are designed for a world where you're running one or maybe a small single-digit number of servers. And that's just not true in the cloud. We run tens of thousands of instances. We provision 60 million instances on EC2 every single day. And so we saw an opportunity here to drive better efficiencies. And because of the scale at which we operate, because of the customers that we have, and the use cases that they have, and the generality of those use cases, it really does become important to be able to take that invention and improve the capabilities for everyone. And so what Nitro does is it removes the majority of the hard work of this big, flabby, janky component of the system, the hypervisor, and offloads it to a custom piece of hardware and some custom services that provides a very, very thin layer on the physical server and allows us to administer those servers at scale. And so what that allows us to do is much more fine-grained, much more high-performance, low-jitter networking. It provides fast access to EBS and fast I/O access to file stores. And because the software that runs on the instance is so much thinner, not only can we provide more of those resources to you, so there's no virtualization overhead, it allows us to do bare metal effectively in the cloud, but it's also a much smaller security threat. The vector of attack is much, much reduced because of this approach. And so you can take advantage of Nitro pretty much anywhere that you run on AWS. It's allowed us to provide over 500 instance types of compute types. And these span anything from general purpose instances, memory optimized, storage optimized, compute optimized, even accelerated computing with GPUs, all delivered through Nitro, far more than any other cloud provider. We're also, through Nitro, able to provide the latest choice of processors, whether you run on Intel Xeon, you're choosing AMD EPYC, or you're using our own custom silicon that I'll talk more about in a minute, or you want to use M1 on our Mac-based instances, or if you want to use accelerators, like GPUs from NVIDIA, we have machine learning acceleration from Havana, and FPGAs available all on AWS, enabled through this Nitro system. Another thing that we can do at the sort of scale that we operate, which would be very hard to do in your own data center, just because it's expensive and incredibly time-consuming for most organizations, is to design custom silicon which we can provide to our customers. And we've been doing this for a couple of years now. We're on our third generation of our ARM-based general-purpose CPU that we call AWS Graviton. Tens of thousands of customers have migrated to Graviton over the past couple of years that we've been offering it. It's incredibly efficient, it's incredibly high power, it provides the best price performance for general purpose workloads in the cloud. And the latest generation, Graviton 3, has 25% better compute performance than Graviton 2. And large customers that have largely adopted Graviton 2 were already seeing 7x performance benefits over their previous architectures. So these things just fly. And price per watt, they are much more efficient than any other processor, about 60% less energy utilization on Graviton 3 based EC2 instances. So if you haven't made the move on EC2 to ARM-based instances with Graviton, I suggest you give it a whirl. You'll see significant improvements in almost all cases. But if you want to just use other approaches, we've baked Graviton into Amazon Fargate. So if you're doing containers, you can just get the advantages of Graviton there. And if you're doing event-based computing with Lambda, you can use Graviton under the hood as well there, and you'll see up to 34% price performance improvements just by adopting Graviton. It's as easy as a checkbox. Or if you're using any of our managed database services or any of our managed analytics services, again, Graviton is just there as a checkbox that you can select. You get all of these price efficiencies, all of this power efficiency right in the tips of your fingers. So there's a lot of advantages to running in the cloud. There's a lot of innovation that at the scale in which we operate at AWS, we're able to provide to our customers. And that invention provides enormous benefits in things that really matter over time: security, price, performance, service delivery, and the breadth of capability that we see. And as a result of all those things, customers are able to build magical, wonderful technologies. And so to hear a little bit more about the types of technologies that are being built on AWS, I'd like to welcome Alex and James from Ocado Technology to talk about what they're doing on the platform. Thanks.
Thank you, Matt. Good morning. I'm James Donkin, Chief Technology Officer at Ocado Technology. It's so great to be here with all of you today.
Hello, my name is Alex Harvey. I am Chief of Advanced Technology. We're really excited to tell you about the journey and the exciting role that AWS has helped play in it.
It was 20 years ago that Ocado made its very first grocery delivery out of a small temporary warehouse north of London. Today, it may be easy to forget the humble beginnings of the online grocery market. Back in the early 2000s, delivering groceries in a profitable and sustainable way was considered an unsolvable problem. Grocery is fundamentally different from any other retail segment. Food needs to be kept at the right temperature throughout the journey to the customer. Freshness is crucial. Customer baskets are large, and margins are razor thin. Today, the shift to online grocery is significant and permanent, a trend that's only been accelerated further by the global pandemic. Ocado started as a pioneer in the online grocery industry, and we've been on a hell of a ride since then. Our first generation warehouses relied on a system with kilometers of conveyors, moving thousands of containers. We completely disrupted that model, and today, our highly automated grocery fulfillment warehouses are the most advanced in the world. As we've followed this journey of serial innovation, we've grown and evolved into a global technology company. We now provide an end-to-end platform for smart online grocery to some of the world's largest and most innovative grocery retailers. To illustrate the scale of our growth, we've deployed 12 automated warehouses or fulfillment centers to date. This year alone, we're launching another 6. And over the next few years, we have 50 planned globally. Our partnership with AWS has played a key role in our ability to scale our pioneering technology to a global market and to achieve efficiencies that set the bar in the industry. We've been working closely with AWS for several years now. We utilize over 80 services to seamlessly scale the Ocado Smart Platform to our grocery partners around the world. In fact, we now promote a cloud-first approach to our builders internally, having realized the benefits of standardizing on native services. We're freeing up our engineers to focus on adding value to the customer offering and leaving the undifferentiated heavy lifting to AWS. Today, we're going to give you a glimpse into one of our really exciting and transformational journeys we've been on, migrating the orchestration of our fleet of bots onto AWS. So at the heart of our model are automated warehouses, which are the most advanced of their kind in the world. These state-of-the-art facilities incorporate cutting-edge automation, robotics, and control systems. Thousands of bots collaborate seamlessly on 3D grids to move totes with grocery items and customer orders for the most efficient fulfillment of online grocery in the world. The bots move at speeds of up to 4 meters per second and pass within 5 millimeters of each other. Now, these bots are not autonomous. They're orchestrated by our control system and our communications technology. This air traffic control system communicates with each bot 10 times each second with ultra-low latency to ensure the most efficient and seamless collaboration among the bot fleet for peak performance and the highest throughput at each site for the lowest cost. So historically, our orchestration was hosted on-premise at each site. In 2020, we took the radical decision to move the proprietary real-time orchestration to the cloud. At Ocado Technology, we pride ourselves on solving problems no one else in the industry has solved before. We've got a long track record of building almost all our technology in-house, as the solutions available in the market are not fit for purpose for the unique demands of grocery. Moving one of our most critical systems to the cloud was a huge decision for us. It was a truly bold move. We had to know, with a high degree of confidence, that the low latency and high predictability we'd achieved on site could be replicated or exceeded in the cloud. Compromising would mean compromising the throughput of our sites and therefore the profitability of our retail partners, nothing less. Alex and his teams championed the idea of moving the orchestration system to the cloud.
Thank you, James. Orchestrating a fleet of thousands of bots is an incredibly tough challenge, even when you host it on-premise. Our air traffic control system receives positional updates from each bot 10 times a second and combines this with intel and knowledge about the placed customer orders and available stock to build a meticulous plan of tasks for each bot well into the future. The tasks are time-stamped with millisecond precision to allow the bot control system to orchestrate each bot to its perfect position at any given time in the future. The position updates include status information such that the orchestration system can adapt the plan in real time if any individual bot is unable to complete its task on time. We strive to extract every last optimization and efficiency from every bot configuration on the grid, so the predictability of the system of this plan is absolutely instrumental to the success. It all comes down to two critical factors: the low latency of the communication from the air traffic control system to the bots, and a very predictable messaging delay of no more than 50 milliseconds. Any variability in the predictability of the messaging delay means that we need to leave larger margins of error, which has a knock-on effect to the fulfillment efficiency and the throughput of the site overall. Historically, we deployed the orchestration system on-prem, so local compute in server rooms with immediate proximity to the bot fleet, with a very high-speed data network to ensure the predictability in this messaging delay required to achieve the optimal throughput. This approach allowed us to reduce the error budgets for the bot messaging delay and messaging variation, and thus be able to guarantee site throughput overall. However, this also came with a cost of needing to provide the tooling, the management systems to coordinate the deployments, the instrumentation, not only for the application itself, but for all the redundancy of the quorum-based systems that it leveraged. It essentially was a full private cloud with all the overhead that it comes with and all of that complexity. An AWS cloud would have to enable this low latency and messaging delay predictability every time and all of the time, wherever in the world our retail partners decided to build their next warehouses. We had a really great degree of confidence that we could hit these metrics in warehouses that were built close enough to the AWS region, but the big question remained, what about if they didn't? The launch of AWS Outpost in 2019 changed that. The ability to take some productionized racks, the same productionized racks that AWS uses in its own data centers, and move them on-prem was the essential insurance policy that we needed to guarantee this ultra-low latency and the bot messaging predictability, even in the most remote corners of the world. At Ocado Technology, we like really stretching goals, and this was no exception. In just 12 months, we had successfully migrated all instances of the bot orchestration application to run on AWS's compute environment, ECS. We were orchestrating over 5,000 bots from the cloud. Today, this number is closer to 8,000. In the next few years, as we deliver more and more of our customer sites across the globe for our retail partners, we will be orchestrating tens of thousands of bots from the cloud. Truly significant feat. James.
Thank you. Alex, I remember those early conversations we had with the wider team on the trade-offs we were facing. We knew it might not be possible to adopt all of the AWS standards we had internally or all of our tooling within the time frame. We wanted to achieve a version we'd be happy to deploy into production at scale, even if it wasn't fully complete yet. We used our advanced simulation capabilities and a series of experiments to answer what-if questions, such as how much latency can we tolerate between our air traffic control system and the bots in the field? How would it run in an AWS virtualized environment? We also gathered data to answer the questions. What would the latency be in the real world? With this detailed characterization about the expected performance, we were able to be confident of achieving the benefits, and Project Tempest was born. We wanted to use the AWS developer platform used across most of Ocado technology, so we'd benefit from the knowledge, tooling, documentation, economies of scale that come with a shared platform. It was a team effort across our business, and here's a few examples. The team building the bots had to rework their applications and modify their deployment pipelines and other processes. Our engineering productivity teams added support for features such as Amazon key spaces and network load balancers to support low latency comms between the orchestration system on the cloud and our bots in the CFCs. And our cloud teams help facilitate a smooth migration from on-premise VPNs through to the cloud. So when it came to migration, we started with our largest fulfillment center in Erith. This approach would help us prove we could run at scale. Erith provides more than 10 times the scale of any other grid in the world. With some of our most technically challenging and latency-sensitive services called to the migration, it was no small feat. We organized trials to steadily migrate critical functions, such as the Erith chill grid, followed by the ambient grid. Each trial meant a database migration to AWS, and then after the trial, back to on-premise. We did the first migration on Christmas Eve once all the customer orders were out. So we had about 48 hours to recover if we needed it. Piece by piece, our team was able to move all our applications and data to an aggressive timetable. Since the migration, there have been no significant outages or incidents, a testament to the planning and execution of the teams involved. But what's next, Alex?
Right, so next. At the start of this year, we unveiled Ocado Reimagined, a series of innovations which represent a step change in the technology powering the Ocado Smart Platform. Our new 600 series bot, the world's lightest and most efficient grocery fulfillment bot, will allow us to build lighter grids, saving time, resources, and running costs. And our new on-grid robotic pick arm, equipped with computer vision, advanced sensing capabilities, will collaborate seamlessly with the bots to be able to pick and pack the customer orders directly from the grid. Together, the innovations are critical enablers for the next generation of automated warehouses, moving our global retail partners past some of the trade-offs that have defined the industry so far to help grow their operations faster through more cost-effective, simpler, more flexible sites with a faster time to go live. As we scale, our partnership with AWS will play a crucial role in achieving the highest possible levels of efficiency. Thank you so much for listening, and if this story sparks some interest, we are growing our engineering teams and would love for you to apply. Thank you very much.
Awesome. What a fantastic story. I can't imagine how much guts it takes to deploy on Christmas Eve, but that is confidence in your convictions. And what better way to segue into this next section? We talked a little bit about what it's like to use the cloud to find new ways, better ways to build existing applications. But as you just heard from Ocado Technologies, the cloud is fantastic at enabling you to build entirely new types of applications. One area that is becoming increasingly popular is the use of machine learning, a technology which has been around for 50, 60 years, but has really matured over the last couple of years, primarily driven through the availability of large amounts of compute to train sophisticated deep learning models in the cloud. But the other thing that's potentially as interesting is just how easy it is to start integrating machine learning into your applications today. For example, just taking a model which could be pre-trained or a model that you've trained yourself and just dropping it inside SageMaker, which now offers serverless inference, a new feature we added only last week. That allows you, without having to manage any infrastructure or auto-scaling, it enables you to start delivering predictions from your machine learning models in seconds without any operational overhead, or delivering ML queries directly inside our databases. For example, you can use Redshift ML to use trained models to select data from your database based on predictions from your machine learning models. So you could, for example, select from a customer database only the customers that were likely to buy a particular product in the next 30 days and use that to drive a marketing campaign, all driven inside the database without having to write any additional code. You just write a select statement as you would with anything else. Or taking rich AI services across a vast variety of modalities like computer vision, language models, personalization, forecasting, search, and many more, and just dropping them in as easily as you would any other API. Or taking the analytics which run inside our business intelligence service, Quicksite, and all of the forecasting and embedded capabilities that use machine learning there, and just quickly and easily taking that whole dashboard, including the forecasts, including the root cause analysis, and just dropping it into any application as easily as you would embed a YouTube video with embedded analytics. Incredibly powerful ways to drive machine learning, not just the modeling, but also the delivery and the integration inside your applications. And speaking of machine learning, under the hood, we're not done innovating there either. In the same way as we were able to develop a general purpose ARM-based CPU with Graviton, we've also been able to develop machine learning-based silicon, which significantly improves both the training time and also the inference speed, cost, and latency of your models. We have AWS Trainium, which is our training chip, which dramatically speeds up and reduces the amount of time it takes to train your deep learning models, or AWS Inferentia, which provides low latency access to your machine learning models predictions running on EC2. These are both custom designed and are available by AWS and are available today. Now, back in the day, maybe 5 years ago, back in the olden days of the cloud, I think it would be reasonable to assume that there was a very kind of region-based approach, that your applications would be uploaded onto one of the AWS regions, and that is where they would run, that's where they would spend the majority of their life. But today, that just isn't the case. Today, you can take the same technologies that we run inside our AWS regions, which are large and built in large redundant ways, but use those same approaches and those same services wherever your application needs to run, pushing it further and further out into the edge and into the real world. For example, you can use AWS local zones, which provide the same database, compute, and storage services that you're used to in our large AWS regions, but builds them into metro areas for very, very low latency access for folks that live there. Or if you want to take AWS on premises, using AWS Outposts. We provide physical hardware where you have the exact same control plane, exact same APIs, exact same services, including compute, storage, and databases, but also using machine learning with SageMaker. And you can deliver that wherever you need compute, into your existing data centers, if you're that way inclined, or into physical locations that don't have data centers but need data locality. We also have rugged edge deployments where you can take pieces of physical hardware that have storage and onboard compute and just run those wherever they need to be run. They're ruggedized, they can withstand depth charge explosions. One of my strangest days at AWS was when I approved the purchase of explosives to test our Snowball devices to ensure that they were able to withstand explosions. But you can take those storage devices, you can fill up the data quickly wherever that data needs to be housed, and then you can just send it down the road to us and we'll load it into S3 for you. You should never underestimate the bandwidth of a FedEx truck loaded full of hard drives. Or if you want to get right onto the wireless networks, we have AWS Wavelength, which embeds compute and storage capabilities directly inside the low latency networks of the 5G providers. So wherever you need to run your workloads, whether it is geographically distributed on our AWS regions, or whether you need to get closer and closer to your customers with low latency but high performance capabilities, AWS has a service for you. And so combined, there is entirely new ways to build pretty much every application. And we hear from customers that they find building is easier, that cost is lower, and that the speed of execution is far faster. And if lower costs are the sizzle of the cloud, then speed and agility is the steak that keeps customers coming back time and again. And the result of all of this is that reinvention is happening in the cloud across virtually every industry. And we've seen this in media and entertainment, we've seen it in manufacturing and industry, travel, hospitality, you name it. And no matter which industry we look at, there isn't a digital transformation story that isn't instantiated, driven, or accelerated by data inside that organization. Data is the driving force for reinvention. I'm going to talk more about that and how you can achieve that on AWS in a second. But to get an in-the-trenches view, it's my pleasure to welcome up on stage a customer from Genomics England, Chris Wrigley, the CEO, to talk about their data usage on AWS.
Thanks so much. I'll be giving prizes halfway through the talk for people who realize why the talk is named in this way. So I'm Chris Wrigley. I'm the Chief Executive at Genomics England. And let's think about genomics. It's the study of our whole DNA sequence. And there's a copy of that in every cell in our body. Now, when the first human genome was sequenced back around the time of the millennium. That was a job that took thousands of scientists, many years, many millions of dollars, even billions. Today, we can sequence a human genome in just a few hours for just a few $100s. And as you can imagine, that's really bringing genomics into the forefront of research and also healthcare delivery. If we think about our DNA, it's about as personal a data set as we can imagine. It's incredibly sensitive, and it's also incredibly large. Each genome is 200 to 250 gigabytes. Depending on your sequencing technologies, that might be up to a terabyte. So as we were thinking about how to scale in line with our aspirations, Genomics England, along with the NHS, is at the heart of the world's largest precision medicine community. It made sense for us to talk to AWS as the world's biggest cloud provider. And there are lots of big numbers involved in this in terms of the variety and volume of data that we work with and process in order to do what we do. In terms of volume, we're the curators and custodians of over 60 petabytes of clinical and genomic data. In terms of variety, we're working with hospital records, DNA itself, RNA, proteomics, and increasingly with high-definition images of things like cancer scans. So I could talk about numbers all day, but actually, to give you a sense of what we do, we need to think about human stories. And in fact, the origin of Genomics England starts with a human story. This is the Cameron family, and the Camerons had a kid, Ivan, who had Ohtahara syndrome. And Ohtahara syndrome is caused by a glitch in the genome, just one change. And that's Ivan there on the right with David and Samantha Cameron. And like many parents, the Camerons rapidly got smart, not just on Ohtahara syndrome, the disease itself, but also on the science and the technology around that, around genomics. And it was with the enthusiasm and support of David Cameron that as part of the Olympic legacy, the 100,000 Genomes Project was born to try and help kids like Ivan. And Genomics England was created as a vehicle to deliver that program in partnership with the NHS. So let's look at one of the participants, a young girl called Jessica. So Jessica presented to her doctors with a range of severe symptoms that were affecting her development, including seizures, and was sequenced as part of the 100,000 Genomes Project. And when we sequenced Jessica's genome, we could see 6.5 million places in the genome where her DNA was slightly different to other people's DNA. But then we use a range of complex algorithms to do the detective work to get down to the one change, the one glitch in her DNA that was causing her symptoms. And happily, we're able to treat her and get her back on the path to a healthy childhood. And it's this linking of the worlds of research, where these discoveries and sort of detective work are taking place, and the world of healthcare, where we can treat patients. It's bringing those together that's at the heart of our model. And we think about that as an infinity loop. The more that we can do in healthcare, the more data we can generate, and with our patients' and participants' consent, de-identify that and make it available to researchers. The more we can do on research, the more insights we can generate, the more diagnostics and therapeutics we can help others to develop. We can bring all of those insights back into healthcare. And so, as we look to scale our activities across this infinity loop, we also realized that to do that, we would need to shift our operations into the cloud. If I look at the healthcare side first, the systems that were developed for the 100,000 Genomes project are now being used to support a live clinical service in partnership with the NHS Genomic Medicine Service. And we needed to evolve our infrastructure in order to be able to scale in that way. It's a highly regulated environment, and we need to be relevant to doctors and patients with fast turnaround times. So working hand in glove with the AWS team and other partners, we developed an approach to doing the migration. We went through a series of reviews of our architecture to make sure it would be fit for purpose and robust. We had a lot of tools that reassured me personally that one huge data set on-prem is the same as the replicated data set in the new infrastructure. And really went at this in a spirit of using as many of the managed services as possible, like Aurora for data and Fargate for compute, so that we were no longer having to do the heavy lifting on that ourselves, but could get the benefit of all of the investments that AWS made. So that whole migration took place over the course of about 6 months, just completed last month. And we, in fact, also had a major migration moment over the Christmas holidays. So touch wood, so far, that's all running smoothly. Critically, our teams can get more innovation into our pipelines, into the treatment of patients faster than ever before. And we're able to scale that infrastructure in line with our ambition to bring the benefits of genomic medicine to everyone. If I flip to the research side, we run a trusted research environment where we house all of this incredibly sensitive data. We think about it a bit like an aquarium, in that you can come in, you can admire the fish, you can't take the fish away with you. So the environment where the researchers work has to meet all of their needs in there so that the data can stay where it is. Over 60 petabytes of data, lots of different workflows that different researchers are doing. We need to be able to support all of that. In this instance, it was actually the COVID pandemic and a research project that we kicked off to understand how our DNA could help us understand the body's response to COVID that prompted us to make a move to a cloud-first environment so that we could scale that and make those data sets available to global researchers. So working very rapidly with AWS and with our sort of biotech partner, LifeBit, we stood up a secure environment where researchers could access all of these data sets through AWS workspaces, underpinned by services like Batch and Lustre FSX. And we're able to stand up that platform at very, very high speed, so that as the data came on stream from the research we were doing with patients, that became available to researchers in a highly pressurized environment. And we were able, through this work, both to identify the glitches in our genomes that could lead some people to respond much more severely to COVID. That led through into the recovery trials and into new clinical treatments for patients, and also to enable all sorts of other research. We just had a big project come out last week with a researcher in Cambridge, Serena Nick-Zinal, on cancer mutational signatures, which we're hoping will also be transformational for many patients. So as we look forward, we're using more and more cutting-edge technology, more and more machine learning to help doctors, to help patients, to help researchers do their work. The world of genomics is moving incredibly fast. The world of technology is moving incredibly fast. And we want to be right at the front of that, focusing on bringing those benefits to as many people as possible, from cradle to grave, to lead as happy and healthy and well lives as they can, informed by the insights that we can generate together. Thank you very much.
Incredibly important work and a really inspiring story. And it really highlights, I think, what you can do with your data when you start to remove the constraints of operating it in the cloud. So when you start to look at a new problem, or you start to form a new business, you kind of get dropped into that problem without really knowing what the contours of the landscape are around you. But that landscape kind of forms the surface area of your business. And understanding that landscape is really kind of job number one in establishing a business which is going to grow, in establishing an agenda which is going to drive innovation, in establishing how you're going to use the information available to you to make better decisions. And one of the first jobs to do is often take measurements of your surroundings, not just individual point measurements, but the measurements in the context of the broader landscape to really understand where the hills are, where the valleys are, where the resources are, and in some cases, where the monsters are hiding. And over time, you'll use those measurements and you'll start to build up a coordinate system of your business. You'll start to understand your customers more deeply. You'll start to be able to use that landscape and that surface area to understand the trends of how your customers are using your products or interacting with your business, what their satisfaction is, and how to drive more engagement over time. You'll start to understand what the direction is, which way is up. And a lot of these measurements end up stored as data inside data stores. And these data stores are kind of like the settlements inside this broad landscape. They are the unique vista on the surface area of your customers, of the surface area of your business. And each settlement, each watchtower, has a slightly different and unique view into your business. And so you may find that there's a unique view from sales and marketing. And you may find that that view is subtly different from the operational view of your organization. It's also worth just gut checking sometimes that sales and marketing or operations are even operating on the same continent. But you get a different, unique perspective. And the data that's available to all of these different settlements, all these different watchtowers, gives you the insights that you need to make decision-making more quickly. And it's very tempting to think of these data stores as just undifferentiated silos of bits, as if every 1 and 0 were created evenly. But that just isn't our experience. And we found that if you really want to make the use of your data, if you really want to take that unique perspective and use it to drive better decisions inside your organization, use it to understand your customers and your processes better, you shouldn't look at your data as if it should be just stored inside an undifferentiated silo. Our approach is a little bit different. Our approach is that you want to actually be able to take advantage of the structure of that data. You want to be able to take advantage of what you know about the types of data that you're going to be storing so that you can drive down costs, you can drive down latency of actually using that data, and you can increase the predictive accuracy of what you're working with as a result of that data. And it's why on AWS, we don't believe and we don't really recommend that there is a one-size-fits-all data store. Instead, you want a purpose-built data store, one that understands the landscape on which it is built and is fluidly in line with that landscape. And it's why we have databases which are custom designed for relational workloads. It's why we have databases and data stores which are custom designed for key values. It's why we have a separate service for managing and storing graph data, and so on through memory and document and caching and time series, anything that you can imagine. And our goal here is that no matter what type of data you're working with, you can quickly find a data store, put your data in it, and start taking advantage of that data without running up latency and without large, complex, expensive queries. So one good example of that is Amazon Aurora. Aurora is one of our most successful, most popular services ever. It's the fastest growing service in AWS history. And we built it and designed it from the cloud, for the cloud, starting with just a blank piece of paper. And so we were able to take advantage of everything that I've been talking about in terms of the cloud scale and efficiency to drive better relational databases. So Aurora is designed to have the security, performance, and availability of very, very high-end commercial databases, but with the simplicity and cost-effectiveness of open-source databases that developers love. Aurora has about 5 times better performance over standard vanilla MySQL, and about 3 times better performance over standard vanilla Postgres, at 1/10 the cost of commercial databases. And so with a few clicks, you can have all of these capabilities available to you for your relational databases. And just to put it in context of what it means to be one of the fastest growing services in AWS history, since 2017, we've seen the usage of Amazon Aurora grow by more than 10x. If you're not already running on Aurora, recommend you give it a try. A similar story is there for Amazon Redshift. Redshift was really the first time that enterprise data warehousing was made available to the rest of us. Data warehousing was once the position of just very, very large, old guard technology companies. It was expensive, it was slow, it was like the definition of enterprise. And I don't mean that in a good way. With Amazon Redshift, AWS was really the first to offer data warehousing as a service, something which was designed to be very, very high performance, which was also designed to be low cost, so that everybody could take advantage of the benefits of data warehousing. And since then, we have methodically been innovating on Redshift. We've added capabilities for data sharing. We've added the machine learning capabilities that I talked about earlier. We have federated query capabilities, which allows you to query all of your data from a single location in Redshift. We have hardware acceleration with Aqua, and so on and so forth. And one of the features I'm most excited about is a new serverless feature, which allows you, with just a few clicks and no ongoing operational costs, to be able to spin up Redshift without managing or optimizing any of the infrastructure under the hood. We take advantage of all of that for you. So we've been systematically improving Redshift and making it easier to use so that to live up to the commitment and the opportunity of providing this technology for everybody. Now, sometimes if your data stores are like your settlements, then a data lake is kind of like your library. This is where you go to accumulate not just data, but to start turning that data into richer and richer information and building knowledge. It allows you to aggregate data from various different sources, store that data in a standardized format, and query it as if it was a single source. And today we have hundreds of thousands of data lakes running on AWS. And it could not be easier to get up and running in just a few days. You can take your data, store it into S3. We provide lake formation to allow you to wrap that data into a governance framework. And then Amazon Athena, which allows you to query that data with standard SQL. So in just a few days, you can start taking your raw data, adding information to it, and adding value to it for your customers and your organization, so you get a much higher resolution of the landscape around you. Now, of course, once you've got these different settlements, it's only natural to assume that these settlements are going to want to talk to each other, to be able to share the information and the knowledge which is building up inside them. And so these routes tend to appear inside your organization. These are kind of like trade routes with people swapping information between the different settlements. And we try and make this as easy as possible on a technical level with a service we have called Aws Glue, which provides a simple, scalable, and serverless approach to data integration, ETL, and cataloging. And we're not done with our innovation here either. Just in the last few weeks, we've added new interactive sessions and notebooks. We've added new auto-scaling for Glue workers, so you don't have to manage the infrastructure when you're indexing and cataloging data. And we've also added automated sensitive data detection, so you can really automatically understand what type of information is available inside your data lakes, inside your data stores, and provide fine-grained governance of that data. And governance is going to be at the core of any sufficiently advanced data strategy. And it is really important to be able to have a set of tools which doesn't just block access to everything, although that's very appropriate in some times, but has a set of capabilities which allows you to find the right balance for your organization, where you have fine-grained, row-level, and in some cases cell-level access to individual items inside your data stores, where you're automatically understanding where the PII is and putting controls in around that. But where suitable, you're also enabling teams inside your organization to collaborate and share that data. So they can take that data in as a consumer, they can add value to it, and they can potentially republish it out to their organization. All the while providing a single point of querying your data anywhere that it lies, whether it's in your data lake, inside your SaaS applications like Salesforce, inside your databases, on premises, in big data engines, or even operational logs. So in our landscape as it starts to grow, the economics and the simplicity of building these data lakes and the value of the value and the opportunity of using data within them to make better decisions will mean that more and more of these data lakes start to spring up. More teams will invest the time to build them. And this, far from being scary, actually unlocks wave after wave of invention and innovation for your teams. To be able to have access to that data, improve that data, turn it into higher value knowledge, and then use that to make better business decisions is an incredibly powerful tool at the center of almost every data transformation story that I've heard. But it also doesn't stop there. The ultimate goal is not to just map the terrain and understand where the hills and the valleys are, but it's actually to make a reusable map for your organization. And if you're doing anything sufficiently advanced with data, believe me, you're in the map-making business, whether you know it yet or not. And maps are great because they provide a way to orchestrate and organize all of your teams. They provide a path from A to B to allow you to understand the trends inside your organization. And one of the ways that we've seen customers do this is with our business intelligence service, Quicksite. So Quicksite is today, we launched it about 6 years ago, and today Quicksite is the most popular cloud-native, serverless business intelligence service in the whole entire world. And customers are able to use this service to build advanced visualizations and to be able to understand using machine learning all the trends inside their business, and then be able to pass those insights to anybody that wants them inside their organization without having to provision desktop software or server software or managed license or any of those things. And because Quicksite is serverless and because it's built in the cloud, we're able to do things there that you just can't do in the old janky world of traditional enterprise business intelligence. For example, we recently launched Quicksite Q, which allows you to very quickly and easily ask natural language questions of your data and get back relevant answers and visualizations in seconds. So instead of having to write SQL queries, you can just ask Quicksite what is going on with your data. So you can say, what is the revenue per feature inside my application? What is the revenue per feature per country? And Quicksite will answer with real answers, and it'll give you back relevant visualizations so you can understand the context of those answers. All very quick and easy without having to be experts in data science. And just last week, we announced the preview of Amazon Quicksite one-click public embedding. So gone are the days where customers have to stop what they're doing and jump to a business intelligence application on their desktop or somewhere else, change context to be able to get their questions answered with data. One increasingly common trend is the ability to be able to take that insight and those dashboards and embed it directly into the applications that they're already using, and to be able to do that at any sort of scale. And so with Amazon Quicksite one-click public embedding, you're able to do that as easily as you are with embedding a YouTube video. You just take a small snippet of HTML, copy and paste it into your application, and away you go. Quicksite takes care of everything else, and you get a live, interactive dashboard available inside your app. So let's take a look at how others are doing this and using data. I can't think of a better example of those that are used to using maps and measurement and precision than F1. Let's take a look at what they're doing.
AWS and F1 partnered in 2018, and since then have helped to cement Formula One as the most technologically driven sport on the planet.
And it's lights out and away we go!
We were able to consider the huge amount of data that was available to Formula One that up until this point, it hadn't really tapped into. How do we present the data to engage the fan more? It was a fairly simple premise on which we built the strategy. F1 Insights are data widgets. It helps the fan to be able to understand at a more detailed level what's going on in a Formula One race. They're a game changer because until this point, there was no way of really understanding all of the details of a Formula One race. We asked the fans what they wanted. They wanted up-close, wheel-to-wheel racing. And that wasn't possible with the current generation of cars. So we had to go away and we had to redesign that car. We needed a technology partner like AWS who helped us to put that whole project together, and hence the results of the new car. So for Formula One to deliver on its future vision, it must engage the right partner. And when we talk about technology and when we talk about cloud services and analytics and machine learning, AWS is that partner.
It's amazing what can be achieved with some data that is collected from those cars. Those cars are data-generating monsters. They have over 1,000 sensors on them per car. And not only were Formula One able to collect all that information and process it, but they're then able to use machine learning to actually make predictions about what particular teams would do or should do on the track. And that's one example and one trend that we see with a lot of customers going through their own transformation. The ability to be able to collect that data, analyze it, quickly leads to teams investing in the use of predictive analytics using machine learning. And AWS has by far the broadest and most complete set of machine learning capabilities. spanning a very wide range of expertise. So at the very lowest layer for folks inside your organizations that are machine learning practitioners and data scientists, we provide a set of machine learning frameworks and infrastructure, including the support for all the most popular deep learning libraries, as well as Trainium and Inferentia, plus GPUs for training. For everyday data scientists and developers that want to get into building, training, and deploying their own applications, we make available SageMaker, which allows you to take all of your data, enter into the world's first machine learning-focused IDE, and then start labeling your data, training your models, applying your algorithms very quickly and very easily. And if you want to get into machine learning without writing any code, we also make available SageMaker Canvas, which allows you to do all of that inside a friendly UI, broadening the applicability of machine learning. And if you're just an application developer and you just want to take some of our pre-trained models and embed them into your application, it's easy to do that as well using our AI services. So machine learning has gone from a set of capabilities which was largely out of reach for everyday developers and is now accessible to all customers. And we are, at AWS, very invested in ensuring that customers can take advantage of some of these technologies. And we have a goal to train 29 million developers in machine learning by 2025. Starting with our own training and certification efforts, we have the Machine Learning University, which makes available the machine learning curriculum that we use inside Amazon to train our own engineers on machine learning, and includes some fun data sets like predicting whether an order should be gift wrapped. We have a partnership with Udacity, which allows customers to take a machine learning nano degree entirely online. And one program I'm particularly passionate about is the AI and ML Scholarship Program, where we're investing $10 million a year to fund scholarships for those that want to get into machine learning from underrepresented communities. And for those of us that like to get more hands-on, we have the Deep Racer League. The Deep Racer League is a global racing league at a slightly different scale than Formula One. We provide a 1/18th scale, fully autonomous racing car, which you get to teach to learn how to drive and race, using real cars on real tracks. And the league has gone from strength to strength over the last couple of years, and so I'd love to take a look at the updates for 2022.
Hi everyone, I'm Ryan Marine, and I'm excited to bring you the next evolution in racing, the world's first global autonomous racing league, AWS Deep Racer. Since launch, over 140,000 developers from more than 150 countries have participated. And this year, the Deep Racer League is more accessible than ever before. With the all-new Student League presented by Intel, high school and college students worldwide can compete for scholarships, prizes, and glory. Students can get rolling with just a few clicks, no credit card required. All new AWS Deep Racer arcades will let you skip the coding, grab the wheel, and race head-to-head against AI. Compete from anywhere in the world in monthly virtual circuit races. And the Summit Circuit is back in person on physical tracks across the globe with more chances to qualify for one of 50 coveted spots in the championships at reInvent. Discover how you can accelerate your machine learning journey at deepracerleague.com.
So we have a track set up here in London for the Deep Racer League that's taking place today. So I guarantee you a smile the first time you see your autonomous car get around the track for the first time. I have plenty of hints and tips for anyone that wants to buy me a beer later about how to get a good time. So we talked about how AWS is really at the center for building every type of application and working with every type of data. And what we see from customers routinely is that these capabilities really, really matter in driving their transformation and in driving the ability to be able to serve their own customers. So that when they have a new idea or whether they want to be able to scale up their business, they no longer have to file their TPS reports. They no longer have to write big checks with enormous amounts of capital. They no longer have to wait hours or even weeks or months. They no longer have to receive the boxes. They no longer have to rack and stack. They no longer have to install, power, and cool their infrastructure. They're able to just get things done. And this leads to incredibly happy developers. And with that, I'll thank you all very much and hope you enjoy the rest of the summit. Thanks a lot.